Hey, we are starting trigonometry. Oh boy, trigonometry. So trigonometry deals with angles, and it can be angles in any shape. We're going to start off with angles in right triangles. So, right here, we have a right angle in my triangle, right? Now then, over here, we have acute angle. So that acute angle has a Greek letter there. That's theta. You see a circle with a line through it like right there. That's theta. Theta. That's what we're dealing with. All right. So all of these things are measured with Greek letter there. So there's going to be three things that we learn today. We deal with sine, cosine, and tangent. And they deal with the relationship of the side and the sides of the triangle, right? So what we have here is the longest side is always called the hypotenuse. You remember that. The longest side is always called the hypotenuse, and so that's over here. It's the side that's away from the right angle. So here's the right angle. The side that's away from it is called the hypotenuse. That's the denominator of these two fractions, right? The denominator of the sine fraction and the denominator of the cosine fraction. So when they're looking at this problem right here, if you're looking at this problem right here, then the sine of theta, remember theta is this angle right here, has to be the opposite side divided by the hypotenuse, which is what we have right here. The opposite side divided by the hypotenuse. Now then, if we were dealing with cosine, cosine has to be the adjacent side. So adjacent means the side that touches the angle. So if we're dealing with this angle right here, 3 is the adjacent side divided by the hypotenuse, right? That's why this one is 3/5. And then the tangent is always the opposite side. Do I have another color? I think I do. Yeah, baby. The opposite side divided by the adjacent side. So this is the opposite side over here, and this is the adjacent side. And so if I take those and divide, I get the tangent of theta. Now, theta changes in every triangle. Every triangle has a different angle because every triangle is going to have different side lengths. Right? And so what we're trying to do is find the sine, cosine, and tangent of every angle in the triangle. That's what we want. So let's look at one right here. And now I've got to get my eraser out. Let's get rid of all these little tiny red dots and green dots, blue dots, orange dots. Yeah. One more. There's one more. I think we're done. All right. So we're looking now at triangle FGH. This is FGH. Let me scoot it over here so you can see the H. You see the H? There it is. FGH. So what's the length of the side that's opposite theta? So here's theta. The side opposite would be this one. So that's fine. What's the side adjacent to it? Well, adjacent would be this one because it's touching it, right? That's ocho. Right? And how long is the hypotenuse? Remember, the hypotenuse is the longest side. It's the side that's away from the right angle. It does not touch the right angle. So 995 is how long the hypotenuse is. So if I want cosine, remember that's the adjacent divided by the hypotenuse, that would be adjacent is the one, the adjacent is this guy, and the hypotenuse is this guy. So if I wanted to write a fraction for cosine, I would have 8 over 995. There we go. All right? That's what cosine would be. And then if I wanted tangent, tangent, remember, is opposite over adjacent. So I look, opposite is this guy. Let me get my other color here. Opposite is this guy. And adjacent is this guy. So tangent would be opposite divided by adjacent. That's the deal. So every time you find one, you're going to be using the side lengths that they give you, and you always want to do what they ask for. So if they ask for sine, it's opposite over hypotenuse. If they ask for cosine, it's the adjacent side over the hypotenuse. And if they ask for tangent, it is the opposite over the adjacent. Right? Now then, what happens if I turn the triangle upside down? Does that make your life harder? It's not supposed to. You're supposed to still be able to do it. Right? So let's see if we can figure it out. Now then, this is theta, and here's the right angle. So do you know which one's the hypotenuse? Which one is the hypotenuse? Yes! 15. Way to go. Way to think out loud. I heard you. Which one is the adjacent side to the angle? Well, the adjacent side is the side that touches it. That would be this side right here. That's the adjacent side, so that's 9. And then the opposite side has to be this guy over here. That's 12, right? So opposite means it's away from the angle. Adjacent means that it touches the angle. And then hypotenuse, that's what this guy has to be. It's always the hypotenuse, right? It's the longest side. So which one is cosine? Now I covered it up so you can't see. So if you forgot, let me go down here. It's adjacent over hypotenuse. Adjacent over hypotenuse. Let me put my numbers back where they go. There we go. Got my picture in the right spot. Yay! Okay. Adjacent over hypotenuse. So the adjacent is 9. And the hypotenuse is 15. Now, if you can reduce, you have to reduce. So I can divide by 3. Isn't that 3/5? I think so. If I divide by 3, I have to reduce. So this is the cosine, C-O-S, and then you put your little theta there. That's it. So this is the cosine of theta. And then, whoop, what happened? And then the tangent is the opposite side over the adjacent side. So the opposite side is this one. And the adjacent side is this one. So if I do opposite over adjacent, tangent would be 12 divided by 9. And then once again, I cannot leave it like that. I have to reduce. So I can divide by 3 again, so that's going to be 4/3. So the tangent is 4/3. Right? That's what we're looking for. The tangent of theta is 4/3. Ta-da! We did it. Yay! All right. Let's do it again on a couple of these other guys. Oh, forgot. one more thing. One more thing. Here we go. We've got some special triangles. Oops, I keep hitting the wrong button. We have some special triangles. And I think I can get them right here, where you can see them. We'll get rid of all this good stuff. And then, there we go. There we go. So these are the special triangles that we're dealing with. 30, 60, 90. Remember, that's the right angle right here. 30, 60, 90. So the sine is opposite over hypotenuse. And so for a 30-degree angle, the sine is always 1/2. Can you believe that? Now, the sine of 30 is 1/2. What's the cosine? Well, it has to be the adjacent side. So the adjacent side is this one. I have to use radicals? Yep, you do. So the adjacent side is the square root of 3 divided by 2, because that's the hypotenuse. You're dividing by the hypotenuse. And then the tangent of 30 is the opposite over the adjacent. So the opposite over the adjacent would be, opposite is this guy, remember? Opposite. Adjacent is this guy. So that would be opposite over adjacent. Ta-da! Now then, that's just 30 degrees. So we have to memorize this, or always keep this sheet with you. When you fill out this sheet, you should always keep this sheet with you, or memorize these numbers, because you are going to use them every day. Quite often you're going to use these things. So let's erase this for a second. Now then, the thing is that these numbers are used anytime you measure an angle. So if I have an angle like this, if my angle now, I'm dealing with 60, if I want the sine of 60, well, the sine of 60 is the opposite. Now this guy's the opposite over the hypotenuse, right? So the opposite over the hypotenuse would be this answer right here. The sine is the opposite over the hypotenuse. Look, the cosine would be the adjacent side over the hypotenuse, right? Adjacent side over the hypotenuse. Ta-da! And then the tangent, according to our rule, is the opposite over the adjacent. Oops, the opposite is this guy. The opposite is this guy over the adjacent. So that's square root of 3 divided by 1. That's just square root of 3, right? Square root of 3 divided by 1 is just the square root of 3. That's easy. Yeah, righty. So let's come over here and do 45-degree angles. So these two answers came from this triangle right here, right? So this special triangle gives us 30 and gives us 60. This other special triangle is going to give us 45. So we need to know this triangle as well, right? So look at this one. The sine of 45 is we'll pick this one, opposite over hypotenuse. So that's 1 divided by the square root of 2. What about adjacent over hypotenuse? Oh, it's the same thing. It is. For 45-degree angles, that's exactly right. So that is that. And then tangent of 45 is the opposite over the adjacent. So this is the opposite side, and this is the adjacent side. What's 1 divided by 1? Ha! It's 1. Yeah. So these are special numbers that you need to memorize. You will have to know these numbers or keep this sheet with you everywhere you go, right? That's what you have to do. You have to know these fractions. These are muy importante por la vida. All right? All right, that's the intro to trigonometry. Well, I'll see you later.